Hi, I am Engineer Jewel Ryan Nicole Birriosa, and for today, this topic is a continuation or a part of our Fundamentals of Algebra. Our topic for today is the laws of exponents, radicals, and logarithms. So let's start. So first up, we have the laws of exponents, wherein exponents are also called or also termed as power or index. The exponent of a number, as defined, it says how many times to use the number in a multiplication. So for example, we have 8 squared, wherein the base is 8 and the power or our exponent is 2. So 8 squared can also be read as 8 raised to the power of 2, 8 exponent 2, 8 raised to 2. So it can be read in so many ways. And then 8 squared is equal to 8 times 8, wherein you have to multiply the base 8 um, to itself because the exponent is 2. So 8 times 8 is equal to 64. Again, 8 squared is equal to 64. So that is one of the most basic concept of exponents. The laws of exponents, also called rules of exponents, come from three ideas or three bases. So first is the exponent says how many times to use the number in multiplication. So for example, we have a number or a variable a raised to n. That means you have to multiply a n number of times. So a times a times a times a up to the n times. So next we have a negative exponent, means divide, because the opposite of multiplication is division, or the opposite of multiplying is dividing. So that means if we have a variable or a variable a raised to a negative exponent, for example, a raised to negative b, that is also equal to 1 over a raised to b, meaning our exponent, negative b, became positive b. However, it um it instead of it having in the numerator, it is now in the denominator. But then the exponent now is positive. So next we have a fractional exponent like 1 over n, means to take the n root. For example, we have here x raised to 1 over n. That means we have to get the nth root of x. So that is all for our basic laws of exponents. Here we have a table of containing more examples and laws with regards to laws of exponents. So we have here, if for the first example, we have here x raised to 1 is equal to x, wherein if a number or a variable is raised to 1, that means it will remain the same. So in our example, we have here 6 raised to 1. The answer is the variable or the number itself, which is 6. And then next we have a number or a variable raised to 0 will be equal to 1. So anything raised to 0 is equal to 1. So x raised to 0 is equal to 1. 7 raised to 0 is equal to 1. And then next we have any number or variable raised to negative 1. That means it will be on the denominator, or wherein the exponent, for example in here, x to the negative 1, the exponent will be positive provided that it will be in the denominator part. Since again, I mentioned earlier on the three bases of the laws of exponents that the opposite of multiplication is division. So for example, we have here 4 raised to negative 1, it will be equal to 1 over 4. So next we have the x raised to m multiplied by x raised to n. You have to add their exponents provided that they have the same bases. So I will be further discussing it later on our next slides. So example here is x cubed multiplied by x squared. That is, let us check first if we have the same base in here, same base, which is x. So x raised to 3 plus 2. So you add the exponents. The answer is x raised to 5. Next, we have x raised to m or over x raised to n, or division having same bases. That is, you need to subtract the exponents of the same bases. So here we have example x raised to 6 over x raised to 4. That is same base x. 6 minus 4, that is final answer, x squared, or x raised to the power 2. Now we have here an exponent raised to an exponent. X raised to the m raised to the power n. So in here, you need to multiply the exponents. So in our example, we have x cubed raised to the power 5. We have x raised to 3 times 5, which is x raised to 15. Now we have here, if you have x multiplied by y, or for example, a multiplied by b raised to n, you have to distribute the exponent to both the variables. In here, the example x and y. So, x raised to 8 multiplied by y raised to 8. So, that is the proper distribution of exponents. Next, we have if it is a quotient. Example, x over y raised to the quantity of x over y raised to n. So again, you need to substitute, or you need to give the exponent n to both the numerator x and both the denominator y. So if you are given the example, the quantity of x over y raised to 4, that means it is equal also to x raised to 4 over y raised to 4. Now we have here, if a number or a variable raised to a negative exponent, again, as an example, we have here x raised to the negative 3. The exponent will be positive provided that it is in the denominator, or again, multiplication is the inverse, or the inverse of division. And now we have here x is raised to m over n. So n, so that will be nth root of x raised to m. So as an example, we have here x raised to 8 over 9. That is equal to 9th root of x raised to 8. Don't worry guys, I will be further discussing it. This is just an overview of the major laws of exponents. But I will be giving you specific discussion about multiplication, division. In multiplication, we have here a general formula. A raised to m multiplied by a raised to n is equal to a raised to m plus n. So, in here, so to multiply two exponential terms, so in our case here, we have a raised to m and then a raised to n. So to multiply two exponential terms that have the same base, take note, it must have the same base. Add their exponent. So in our example here, we have the same base, which is a, and then the exponents are m and n. So again, in multiplying this, you have to add their exponents. So as an example, we have here 3 squared multiplied by 3 cubed, first you have to check whether they have the same bases before multiplying it. So we have here the same base, which is 3. So 3 raised to first exponent is 2. And the next exponent is 3. So 3 plus 2 is equal to 5. Our answer is 3 raised to 5, or multiply 3 5 number of times, since that is 3 raised to 5. That is 3 times 3. So 9 times 3, 27 times 3, 81 times 3, that is 243. So again, this is just a simple note. Do not add the exponent of terms with unlike bases if you are multiplying exponents. Do not add exponents of terms with unlike bases. So next we have here division. In dividing exponents, so to divide two exponential terms, so in our formula here, we have two terms, which is a raised to the m and then a raised to n. So to divide this, you have to subtract their exponents. I was about to say opponents. So to divide this, you have to check first if they have the same base and then subtract their exponents. So as an example, we have here 5 raised to 6 divided by 5 raised to 3. So first thing to check if they have the same bases. Yes, they do, because the same base that I am talking about is 5. So 5 raised to 6 minus 3, that is 5 cubed, or 5 times 5 times 5, which is 125. Again, simple note only. Do not subtract exponents of terms with unlike bases. So I hope the difference between division on the method on how to multiply and divide is clear to you. So we now have here exponents of exponential terms. So how this part will be focusing on how to raise an exponential term to another exponent. So we have here to raise an exponential term to another exponent, multiply the two exponents. So we have here the exponential term a raised to m, and then it is also again raised to the exponent n. The formula here is you need to multiply the exponents, meaning that is equal to a raised to m times n. So another example here is also when the term 3 squared is raised to another exponent cube, we have here 3 raised to 2 times 3, which is 3 raised to 6, which is 3 times 3, 9 times 3, 27 times 3, 81 times 3, 243 times 3, that is 729. And now we have here products raised to exponents. So we have here product of a and b raised to the exponent m. So to raise a product to an exponent, so we have here the product of a and b, and then that is raised to apply the exponent to each individual part. So we have to apply the exponent m to a and then to b. So our answer here is a raised to m multiplied by b raised to m. So here's an example of that. So 5x, so the product of 5 and x raised to the 5th power is equal to 5 raised to the 5th power multiplied by x raised to the 5th power. So that is 5 times 5 times 5 times 5 times 5. That is equal to 3,125 multiplied by x raised to 5th, or raised to 5. So final answer is 3,125 x to the 5th. Now we have here quotients raised to exponents. So that is our a divided by b raised to m. To raise a quotient to an exponent, apply the exponent again to each individual part. So we have here a as the numerator and b as the denominator. You have to distribute the exponent m to the numerator a and then to the denominator b. So your answer will be a raised to m divided by b raised to m. So as an example, we have here 3 over x raised to, the quantity of 3 over x raised to the exponent 3. So you have to substitute or distribute the exponent 3 to the numerator 3 and then to the denominator x. So 3 cubed is 27, x cubed. So we have here final answer 27 over x cubed. So now we are done with the laws of exponents. Now we proceed to the laws of radicals. So radicals, technically, they are another form of exponents, and these radicals are very helpful, most especially in calculus. To rewrite, it is most ideal or it is highly suggested to rewrite radicals in exponential form for an easy solution. So again, all exponential rules or all rules of exponents apply to radicals. Now we have here next. Ayan. So these are some few laws regarding radicals. Ayan. So a raised to 1 over n. So if a number or a variable raised to a fraction exponent or 1 over n, that means you have to get the nth root of that number. So a raised to 1 over n is equal to nth root of a. And now if we have a raised to a fraction m over n or an exponent m over n, you have to get the nth root of that variable or that number raised to the m exponent. So if you have a raised to 3 halves, that is equal to the square root of a cube. Now we have here, so if the nth root of a is raised to the exponent n, that means it is equal to a. Because technically, because nth root of a is equal to a raised to 1 over n. And then if a is raised to 1 over n, and then you multiply n, that is equal to n over n. Wherein n over n is equal to 1. So if any number raised to 1 will remain the same, all will always be equal to the given itself. So a raised to 1 is equal to a. So that is one basic example of the rules of exponents. So if we have here nth root of a product, a and b, so you can simplify this or further expand or evaluate this as nth root of a multiplied by the nth root of b. So if we are talking about quotient, and the quotient of a and b, so a divided by b, and then they are enclosed with an nth root or a radical. We have radical. We have here, you can express this at nth root of a divided by the nth root of b. And then we have here another also which can help you in your future solution. So nth root of a raised to m can also be nth root of a raised to the exponent m. And then we have here the nth root of a. So it is also enclosed into the mth root, the mth root of the nth root of a is also equal to mnth root of a. So I hope that you can now relate the rules of exponents and radicals. Before we proceed with the laws of logarithm, I just want to clarify that radical is the root sign or any higher root sign, and then the radicand is what is inside our radical sign. So laws of logarithm. So if we have a number b or a variable b raised to an exponent c that is equal to a, then log of a, the logarithm of a base b is equal to c. So a logarithm, like the radicals, is just another way to write an exponent. So if you want to find out, for example, what 5 squared is, you multiply two 5s together. That means 5 times 5, which is obviously 25. But if you want to find out which power you have to raise 5 in order to get 25, you use a logarithm. So, for example, what is the logarithm of 25 base 5? So, the question that must be in your mind when you read this, or when you were asked this question, is when you look at this log, it must be the question must be like this: to what power should I raise 5 in order to get 25? So, to what power should I raise 5 to get 25? The answer is 2. So, the logarithm of 25 base 5 is equal to 2. So, that is just a simple introduction about logarithms. Now, we have two major terms here about logarithms. So, we have the common log and the natural log. So, logarithms can have any base, b, but there are two most common bases, which are 10 and e. So, logarithms or logs with bases of 10 are called common logs. And often, the 10 is left out when a common log is written. So, log of 100 base 10 is also the same as log of 100. And then we have here, logs with bases of e are known as natural logs. So, the shortcut version of the, for example, logarithm of x base e is ln x. So, the short term of logarithm with base a is ln. So, that is natural logarithm. So, e is a constant with an approximate value of 2.71828. And you can see that in your calculators. That is an infinite number. And that is also a special number. So, next we have simplifying logarithms. So, the following rules that I will be mentioning for simplifying logarithms will be illustrated, or we will be using examples specific for natural logs or ln, but then these rules apply to all logarithms. So, here we have adding logarithms again with the same base. So, ln A plus ln B, or since ln is a short-term version of our logarithm with base e, it can also be represented by logarithm of a base e and plus logarithm of b base e. But then, the most important thing here is that they still have the same basis. So, we can apply this rule. Two logs of the same base that are added together can be consolidated into one logarithm by multiplying the inside number. So again, if we have the same base and we decided to add this, for example, ln A plus ln B, that is also equal to ln A multiplied by B. So, we have here a specific example. So, ln 5 plus ln 4 is equal to ln, wherein the quantity of the ln is 5 times 4. Or simply, that is equal to ln 20. You can use your calculator to verify this rule. So next we have here subtracting logarithms, again with the same base. So ln A minus ln B is equal to ln A over B. So this is the statement. Similarly, like the adding of logarithms, two logs of the same bases being subtracted can be consolidated or can be considered into one logarithm provided that you divide the inside numbers. So, in our general formula here, we have A and B. So, since we decided to subtract them, our resulting logarithm is A over B. As an example, we have here ln 9 minus ln 3. So, we have to divide 9 and 3 to get the answer. So, ln 9 divided 3 is equal to 3. 9 divided by 3 is 3. So, our final answer, ln 9 minus ln 3 is equal to natural logarithm 3 or ln 3 or log 3 base e. So, that is all the same. Now, we have here exponents of logarithm. So, a logarithm, for example, we have here ln A, wherein A is raised to B. That can also be considered as B ln A. So, the statement goes like this. If the inside number of the logarithm, so in our case here, the inside number is A, is raised to a power, that power is B, you bring down the exponent as a coefficient. So, you bring down the exponent B as a coefficient of the entire logarithm ln A. So, as an example, we have here ln 3 squared. We can convert this as the exponent 2 as a coefficient of our equation or our logarithm 3. So, our final answer is 2 natural logarithm of 3. Or, you may also again write this as 2 logarithm of 3 base e. So now, these are sample or things that cancel, which is very important in logarithm. So ln e, that is equal to 1. Since that is also logarithm of e base e. And then logarithm of a base a, that is also equal to 1. Since a raised to 1 is equal to a. Again, that is always related to the laws of exponents. ln 1 is equal to 0. And then, because e to the 0 is 1. Logarithm of 1 base a, that is equal to 0. Because a raised to 0 is equal to 1. Or anything raised to 0 is equal to 1. And then e raised to ln x is equal to x. And then ln e raised to the x is equal to x. Yan. So, that is all for today. I hope you learned a lot with this content. I enjoyed making this. So, if you wish to have a copy of this PowerPoint presentation and a complete module of Fundamentals of Algebra, this Laws of Exponents, Logarithms, and Radicals, the fraction and decimals, and then the Fundamentals of Algebra is all part of my module, which is about Fundamentals of Algebra. So, kindly email me at ryannicole05@gmail.com. Thank you very much. Have a good day. So, bye for now, and I will be see you in my next videos. Thank you very much.